Do we have any one of you waiting in the list? This one for the course group? No. All right. So today we're going to formally start this course. Well, by formally starting, I mean we're going to get into programming. The other class we just talked about the course. We talked about the grading guideline and stuff. I'm going to give out the course outline in the next class, not today. I wanted to, but couldn't manage time for that. So before I get into programming though, I want to spend a little bit of time talking about Java. We covered programming language C in the previous course, and now we're moving to another course, a new one. Okay. So before learning a language, you should really invest some time learning about the language to know what it is used for and what are the scopes for you with that. Okay. I'm not going to go into the exact details, like what are the tools that we're going to build for that. We will see that in the course. The stuff that we will be covering, let me say something though. The stuff that we're going to do here, there will be some graphical user interface for some of the tools that we haven't done before. Like you can see, we have built programs for console applications. But here we'll have windows, we'll have text fields, we'll have buttons, we'll have menus, and all that. So they will look like modern day software, not something from old days. That's a good thing. And with Java, it's not just limited to that. You can also build applications for the web. You can build web applications, but this is not something I'm going to cover in this course. We have another course called Advanced Java, and stuff like these I usually cover there. And also for building up enterprise level software, those things are covered there. With Java, you can also build Android applications that you can run on your smartphones. This is something I want to touch towards the very end of this course though. So that's still on the target. And Java is such a beautiful thing. You can deploy it anywhere. It can run on any device that can support something called a Java virtual machine. So yeah, it has a lot of applications. You can use it in a lot of places, starting from desktop computers to mobile phones to embedded devices. You can put it anywhere. So that's why it has a lot of reach. And to see how useful it is or how popular it is, I'd ask you to look into something called TIOBE index. So there is this company TIOBE. They look into software quality and they prepare an index every month that shows how popular a language is. Okay. So this is the statistics from January 2017, and as you can see, the rating for Java is 17.278. Okay. I'd ask you to search this search on Google for TIOBE index, and if you read through, you'll see how they do their study. Okay. I mean, this is not the real figure. They even say that it's not the real thing, but this is some sort of an indication of how popular a language is. They collect data from search engines, how much people search for a particular language, and do a study based on that. So if you look at the top two lines, this blue line is for Java, this black line is for C. They're the top two languages right there. It's a good thing that this is what we pick for our first two languages at Southeast University. It may be misleading when you look at the job market for Bangladesh, because a lot of things that we do, they are related to web programming, and still today, PHP is a leader in Bangladesh job market. Okay. But if you want to position yourself in the global market, then PHP is not the one to pick. You'd probably be better off learning Java or C something like that. There are a lot of projects that you can work in. I'm not undermining PHP.
So what are the top 5 for job in Bangladesh?
Well, if you're looking at the job market, I mean, first of all, I would say that it has to be web programming, something related to that. And also the CMS tools that people use. Yeah. That's one of those. There are a lot of freelancing opportunities, and we have some companies that bring jobs and then get people employed for that. So that's another thing. You can do it yourself, but you can also work in a company that actually looks for jobs. So those things are very popular in Bangladesh, but there is a growing business in terms of game development, mobile application development. Those things are coming up. They are not so popular, and also, I mean, it wasn't easy either. But it's a growing market, so by the time you graduate, I guess there will be a lot of job opportunity in that sector as well. So things are changing. I mean, it's a changing spectrum based on how the languages are developing and what sort of jobs we can get. But if you're working in Java, there's a lot you can do. But at the same time, I don't want to mislead you. Just the knowledge of Java from CSA 2015 will not take you a lot further. Okay. We will learn a lot of things. We will learn about databases, how to connect to them. We will learn about networking, how we can communicate with other computers. We will build a lot of tools for a lot of projects. That said, when you go into the job market, the first thing they would want you to know are some frameworks. There are some predefined rules, predefined set of tools that people use for productivity. And you can do something on your own from the scratch, but there are already well-established way of doing that thing because people have done that already, those sort of things. So that's where the frameworks come in. Even for PHP, I mean, you probably know these things, like you probably heard the term Laravel. That's another framework that goes with PHP. So learning just raw PHP wouldn't land you a good job. You can do some small projects or even big projects, but they will be hard to manage. But if you know some frameworks, then they're better managed that. But this is a introductory course in programming, this Java course. We're not going to go into frameworks, but when we go into advanced Java, it's all about frameworks and how you can get those things done in a really fast way and also in a manageable way. So what I want you to take from this is that, well, this is a really important course to do, and also this sort of a foundation in object-oriented programming. But you shouldn't just stop right here. After you're done, it's up to you to take how far you can take it. And then again, it depends on your preferences and what you like. If you don't feel like you love Java, you feel comfortable in Java, then drop this language altogether. Okay. At the end of the day, the language you pick, you have to be comfortable in it. And you have to write a lot of program in it. If you feel that Python is your choice, go for that. If it's C++, that's fine as well. People can write a lot of things in any of these languages. Okay. So the focus over here was just to show you that it's a popular choice. By no means it's a bad language. There are a lot of things that we can do, and we will do a lot of things really in the course as well. What I have planned for today is not a whole lot though, but we will cover some ground stuff. Like we will see what goes behind the scene, how we compile stuff, and I will also show you how I'm going to share my code with you throughout the course. See, I've been doing this for the last few semesters in all my courses, pretty much all my courses. They're all programming related courses, so I need to share what I write in class. That's why I'm going to use a tool called Git. Okay, this is not related to Java. I mean, you can use any sort of language, and if you want to manage your code, if you want to work in a team, this is a really good choice. So what Git is, it's a version control system. The idea is that when you're working in a team, there will be a lot of people writing code at the same time. There will be a lot of files to maintain. Right? I don't know if you have this opportunity, but if two people are working on the same file, there can be a lot of problems with maintaining the state. What I see and what you see and what you type. Those sort of things are now addressed in a really nice way if you go into cloud computing. Have you looked into Google Docs? Docs.google.com or sheets.google.com. You can have spreadsheets, you can have documents, and you can work in a team. Like multiple people can work on the same file at the same time. I think you have seen that, like the course distribution worksheet that I shared with you guys before we start semester. That's actually done in one of those cloud services. So why I talk about that is that it lets us work in a team. Like Shahriar sir and I, we work from home on the same spreadsheet. We talk about how many sections we're going to open for each of the courses. Now, when we talk about programming, if we are working in a large team, then there will be a lot of files to work on. It's not just a Word document, it's not just an Excel file to maintain. You have to write some statements, you have to get them compiled, and in the meantime, if someone else changes that file, everything will be a mess. Because you have your idea that this is what I have, these are the changes that I'm bringing into the system, and I need to test this out. And at the same time, if someone else is bringing something in the system, and if that person's code is not done, then you're stuck. Right? So a version control system allows you to handle these things. That you can make branches of the code, you work on your branch, and you send it out to the testers to see if there are any problems. If everything is fine, then they are included back in the main branch. So that's the sort of idea that you'd be using when you go into the industry. You probably haven't seen GitHub before, but I mean it's an important thing to get familiar with, because as soon as you walk into the industry as a software engineer or anything that has to do with software development, then chances are you'd see Git. And if not Git, you'd find something that's very similar. It could be Mercurial, it could be what's that called, SVN. There are many different version control systems, but these days the most popular choice I find is Git. So how do we use Git? It's not really easy system to use, but the stuff that we'll be using over here, they're not really complicated. I'll show you exactly what to do, but to go into the advanced stuff, you need some maturity, and I'll see how much I can cover off Git in the course. Don't expect a whole lot over here. It's a fair bit advanced thing. So, like I said, the tool that I'm going to use is called Git, and to use that, I will go into github.com. It's a hosting service, and that's how I see it. You can host your code through GitHub. This is not the only one that can host GitHub, Git-related stuff. There is also something called Bitbucket, and there could be other hosting services as well. I use GitHub and Bitbucket, both of them. For this course, I think it's easier to use a public thing like GitHub. So you can go here to github.com and create an account for yourself. I'll encourage you to do that, but this is not by any means required for this course. See, I will be signing in just because I would like to add some stuff. Alright, in github.com I have a lot of repositories for my courses. So the one that I want to look into is Spring 2017 Java. So like I said, you don't have to create an account on GitHub, but you'd have to go to this site, this link, to download our code. Can you guys work with me? I'm just going to grab this URL and put it here. So I'm asking you to visit this site. And once you're here, you'll see that there is a green button that says clone or download. We got two sections this semester with me, and in the other section I wrote some code. I've already uploaded those through GitHub. So let's get started with that. Let's see what we did in the other section, and whatever I do in this section, I'll put that into GitHub as well, right in this class. See, there's this clone or download thing. You can click on it, and there is one really easy option that says download zip. Okay. This is the simplest and easiest way to get the code. So you can download the zip, and I got this thing downloaded. I can open this up, and then I need to extract this somewhere on my computer. So let me extract this on my desktop just so I can get there easily. It's done. And if I go to my desktop, I can find that directory here, and inside that directory I have the codes from the other section. They will all be in the same place. And you'd have to open up your IDE of choice, and then open the project from there. Okay. So let me know if you're all with me. Have we managed to download this zip file, and also have you managed to extract them somewhere on your computer? You have to open that with link, please. So for those of you who have downloaded and extracted these files, the next step would be to get your IDE to open those things. Okay. The IDE that we're going to use is called NetBeans. It's a free IDE. You guys are familiar with the concept of IDE, I think. You have used code blocks for your C, and this is thing similar to that. It just has a lot more features than code blocks. So very powerful and resource-hungry IDE. There are many other good IDEs for Java. You could also pick Eclipse if you want. You could also go with IntelliJ IDEA. That's another really good IDE. But I find that this is very intuitive for beginners, this NetBeans. That's why I'm sticking to that. Okay, so once you have extracted all the files, what you can do is you can go File, Open Project, and then you'd have to browse for that particular project. Here, like for myself, I downloaded that onto my desktop, so that's where I'm going. And over here I go into Spring 2017 Java -master, and the first thing that I want to pick is this Hello World example. So let's go with that. Open project, and then you can click on the source package, and there's this Java file. So this is the source we wrote in that class. It's a really simple program, and if you click on this play button, then you'd see the output. So that's the whole sequence. I mean, if you want to follow the easy route, what you'd have to do is you have to go to this site where all our codes will be hosted. Okay. The next thing I'd ask you to do is to download it as a zip. Download the whole thing. Once you have downloaded that, you extract it, and then you open NetBeans, go into File, Open Project, and open the project. And it would work for all the codes that we're going to throw into GitHub. Let me know if you're facing any problem with this. Like when you download and extract it, you have to remember where exactly you have put it, because that's where you have to get it out from. You're not supposed to open that there. You have to open NetBeans first. Press the start and then type in NetBeans. Just press start and then type in the address. And it means just one word. It's over. Yes, sure. So go into file.
I went there and I choose the project folder.
Let's try to take it up. Let's start with this again. Alright, go to file. Do we have any open projects already?
There's one reference.
There are a lot of stuff over here. Existing evidence of proposal files. Yeah, that's fix. Just writing out this. Let's see what happens. Where did you download and extract those? Where? So scroll down, sorry. Let's go back. Scroll down. That's the project here, you can activate this play button to run it. It's running, right? So I guess we are all good to go. We know how to download this thing and we are able to open at least one of the projects and then we can run this, alright? So once we are done with the project, you can leave it here, it's not a problem. But if it gets messy, if you have a lot of projects open, and then sometimes it's difficult to manage all of that, you can simply hit go file and close all projects or close that particular project. And if you want to open it again, the same thing, go file open project and then browse for that. So I'm opening a different project here, and this is the source code for that. We can hit this play button and it simply compiles and runs it just like that. So that's briefly showing you how you can download what we do from here. That's one of the ways to do this. Alright. But notice that every time I upload some new stuff, you're going to download everything from that site. And that really makes no sense because you have already downloaded the stuff that we have done before. So for example, if you're working from home and you have downloaded today's lecture and all the codes that I have uploaded there, when you go into there tomorrow and I have added some new stuff, you only want to get the new stuff. You don't want to get everything again. Although it really doesn't matter, like the amount of code that we're going to throw in, it's not going to be a whole lot. Maybe 10 megabyte or so at the end of the semester. Because we're not putting in video files or audio files inside this repository. It's just going to be some source code, some compiled stuff, those sort of things. Now, You can always just download this as a zip, but there is a better way, but a slightly more complicated way of doing this. Let me show you that. So I want to close this again. What I'm going to do here, under clone or download, if you click that green button, or the drop down rather, if you click on it, there is one option to download the zip, which we already tried, but there is another option that lets you copy an URL, a link. Okay, so you can copy this, and then you can go open this NetBeans, and then go into team, git clone, team git clone. Let me write this down. Okay, so grab the URL from GitHub. The URL that I got is this thing that ends with .git. Then the next step would be to open NetBeans, and after that you go into team git clone, team git clone. Alright, so team git clone, you have to, whatever URL you got, you throw that in repository URL, the very first box. And under user credentials, the username and password, you can just leave it blank. If you do have a GitHub account, you can throw that in. But this is really necessary only when you're trying to upload stuff by yourself. If you're only downloading them, then it doesn't matter. You don't need a user account. Okay. Now, there's one more important thing. You see, if you go further down, it says specify destination folder. So this is the place you'd want to download your files into. Now, for example, I want to put these things under NetBeans projects in my home directory. If you want to put it on your desktop, if you want to put it in your documents folder, you can do that. So this is up to you. You can change the location. Alright, so once you have pasted the URL, you have to give the clone location, and then you press next. It's going to go into that repository. It's going to select different branches. Well, I was talking about branches that when we are working in a team, if I want to add some new stuff, I'd create a different branch, I'd do my stuff, and then leave it there for other people to see. So over here we're just going to use one branch. I don't want to make this complicated. Just hit next. There's nothing new really. Like when you hit finish, everything will be downloaded and extracted for you. With a zip file, you had to download the zip file, you had to extract it to yourself. But if you clone this, they will automatically be downloaded and extracted on your computer on the location that you set. So let me just show you what happened here. If I go to my home directory under NetBeans projects, I'd have Spring 2017 Java. See, this new directory is here now. It wasn't there. And I have all these files downloaded. Okay. Now after that, it's the same process. You'd have to go File, Open Project, or there was this button there that would allow me to do that. So go into my home directory and then NetBeans projects, and under that I have Spring 2017 Java. I can open this console calculator, and then I can just run this code to get the output. So
how to refresh the server? I mean, getting the Git.
How to get that? Yeah, well, that's the important thing. Like, if you're going to clone this, or if you're going to download it as a zip file, means the same thing really. You're going to get the whole thing every time. But this is not what we want. Alright. For example, I make some changes to this code, or I add some new projects, or add some new files, and you only want to get the new ones, not the old stuff again. Then you're not going to clone that. you have to clone it only once, and to get the latest changes you go into team, remote, and then there is this option pool. So for all the new changes, this is what you're going to do. You go team, remote, pool, then you get the new changes. But I must warn you that this may fail if you download the stuff that I'm putting in, and if you make your changes to those files. When you download with this team, remote, pool, it's going to create some conflicts because my copy will have some edits and your copy will be different. So there will be a conflict. I'm not saying that don't change my files. You must change my files. There will be a lot of homeworks. I'd ask you that, I did these things in class. I'd ask you to change those codes in one way or another. But it would be a good thing to do that, create another copy of this project and then work there. Okay. So you'd have two versions. One is what I upload here, and when you're working on your copy, you just make a different branch or just make a different copy and work there. But like I said, to get what I do, clone it once, and after that just pull from the team remote. Alright, so let me show you, this is how you're going to download what I do in class, but we haven't done anything by ourselves yet. Okay, we haven't written a single line of code by ourselves, so let us start from the scratch. So let me close this project. Okay. The way we're going to write this program to say a simple hello world, what we're going to do is we are going to create a new project. Alright, so when you create a new project, you'll find a wizard that guides you through what sort of project that you're going to create. Like I was saying at the start of the class, that with Java you can do a whole lot of things. You can build web applications, you can build graphical user interfaces, but right now we are starting off with really simple stuff. Very simple console application that just says hello world and nothing else. Alright, so we're going to go with categories Java, project Java application, and then I have to choose where I want to save this file. And let me put it down under Spring 2017 Java right there, and I'm going to say this is hello world section 4. Okay, hello world for section 4, and let me just hit finish. I'm not going to talk about the package and the main class, all that. They will make sense later on. So I have a lot of comments. I have some stuff that's already written for me, and if you remember from what you did in C, there was something called a main function, right? That's where our program starts from. And in Java we have a similar concept. See, there's something called public static void main. Okay, we're going to write our code there. In today's class, I'm not going to talk about all these things. I'm not going to explain what public means, what static means, because they won't make any sense when you don't have idea of object-oriented programming. But in the next few classes, when I introduce object-oriented programming, I'm going to answer each of these things. Like, I will say exactly what do they mean and why they're important to write. So for now, just bear with me. Let's just take it for granted, or just memorize these things, that these are the things I have to write. But I will explain why we need that. So we're going to print a hello world. And the way we're going to do this is we're going to just say system.out.printf. You guys remember printf, right? From C. So we're going to say printf like that. So system.out.printf hello world with a new line. I wrote that, and then I'm going to hit that play button that compiles and runs my code. I see hello world printed just there. Okay, and before I go any further, let me upload this code so that you guys can find this new piece of code in our GitHub. So our GitHub has console calculator hello world section 3 so far, but not something for section 4 like this section yet. So what I'm going to change that. It's a multiple step process. I have to add these things, I have to commit these changes. And then I'm going to push that into GitHub. So that's getting uploaded into GitHub. It needs my username and password because I'm uploading stuff. It's not good. Oh, I see what happened. The username is wrong over here. Okay, so that's done. And if I refresh this, see, we have a new project right there. So right now we got 3 projects. I can download the whole thing again, just like this. Or if you just want the latest changes, if you have downloaded that or cloned that before, you can go into NetBeans and you can go team, remote, pull, and that's only going to pull the latest changes, not something else. Like if I pull now, there won't be any changes at all because it's all updated and nothing will come in new. But you can follow this practice at home. Like all my changes, you can download them just through remote pull. And if you find that difficult, just clone that, or you can just download the whole thing as zip file. Whatever suits you best, follow that. But when we are going into industry, we look into creating branches and then committing these changes, okay, resolving conflicts. Alright, so are you guys with me so far? So far we have written a code using an IDE and everything is hidden to us. Like there is a lot of lines that's here that probably don't make much sense, and it wouldn't at this point. But we have a lot of lines, like 22 lines for this simple hello world. We don't really need that. It's all written and most of it is in comments. We know how comments look like in C, right? You can do a block comment with a slash and star slash, and you can also do single line comment like you did in C with 2 slashes. So that's still valid. So what I want to do now, I want to close this out. I'm done with this. I've already uploaded my code and there goes my NetBeans. I don't want to use this. I want to look into the background stuff, what happens behind the scene. The code that we write, how we compile them, and how we execute them. It's important to know what goes behind the scene because we are studying computer science. Okay. And the IDEs are really powerful these days. You don't really have to know a lot of things. They will do it for you in the background, but it's good to know these things. And whatever I'm covering right now, I'd ask you to review that when you go back home. And for that, you'd have to read the textbook. So let me tell you the reference that I want you to follow. Actually, the textbooks, they're all uploaded in our course group. If you go into the links section, from more, if you go into the links, you'd find Java books link there. So if you go there, the book that I'm going to refer to you right now is Head First Java 2nd edition. Okay, so let me download a copy for this. How big is this file? 10 megabyte. Alright, let's just wait a little bit. It's going to be here. What? Downloads. Okay, first Java. Okay, there's another one, but that's 36 megs. I'll leave it there. I mean, let's progress with the lecture, and in the meantime, if it's downloaded, I'll talk about it. So what I wanted to do now, I wanted to write a simple Java program, the hello world stuff really, but I want to do it in a text editor without the help of any IDE. Like if you're using Windows at home, you know that there is a notepad, and the notepad that I have here is not called notepad, it's called gedit. There are many editors in Linux. I'm just using gedit. Okay, so this is gedit. I want to write the code here, and I want to compile and run it. Let me bring up something that's already known to you. It's a hello world program in C. Can we write that? Goes something like this. Include stdio.h because we have to do some input-output processing. Not really input, just an output. Then we need a main function, and then we write printf hello world, and after that we are returning back to the OS. That's all, right? In C. And let us save this thing. Let me save it on my now let me create a new directory for this. So I have this hello.c because every C file, the source files, they are saved with a .c extension. So as I have saved this thing, let me go back to my desktop. There is this new folder now, and it has one file, hello.c. Okay, I want to compile this file and I want to run this file. I could have done this with code blocks. You guys know how to do that. I mean, creating a new project in code blocks to write a C program, we have done that in programming language C course. But over here, I'm not using any IDE. This is not an IDE, it's a simple editor. There is no compile button, there is no run button here. Okay. So I've written that, and let's try to run this program and see what happens. So we'll go into my desktop, CD is for change directory. Okay, I'm going to my desktop, then I'm going to hello world. By the way, whatever I'm doing here, you can sort of do the same thing on your Windows PC, but some of the commands will be different. Like to bring up a console like this, a terminal, you'd probably be writing CMD.
Yes, sir.
And the same thing goes. CD is for change directory, you go into a particular directory here. But the next command is going to be different. I want to see the list of files in that directory. The Windows command for that is dir. Okay. But over here I'm going to use ls just to show you that ls is for directory listing. So there is this file hello.c, but I can't just say hello.c like this and this program doesn't run, because this is a source code. This is not executable, right? On Windows, how do we know that we can run an application?
Well, if the file is there, it's .exe.
Yes. On Windows, if we have a file that ends with a .exe, then that's executable. Or there are some other variants, like if it ends with .msi, then that's an installer. You can install an application. So the file extension tells you what you can do with it. Excuse me. Last question. Sorry about that. So the file extension tells you whether that's executable or not. And this is a plain text file, but if you have an executable, you can execute that. Even if you're using code blocks on Windows, when you compile something, it produces an executable for you. It produces some .exe for you that you can double click and run, or go to the command prompt and run from there. So I'm sort of going to do that over here, but in a different operating system on Linux. We got that source file, and I want to compile this. Okay. So the way we compile this is by typing gcc, GNU compiler collection. That's the compiler, and then we type in the file name hello.c, and it says nothing because there are no errors in this code. If there were errors in this code, let me bring in some errors. Let's say I forgot about putting that semicolon in after return 0. If I save this and run gcc, now it complains because there are some compile errors. If there are no compile errors, if everything is fine, then it's going to say nothing, right? And if I do directory listings, now I see that there are 3 files instead of 1 file like we had before. Well, the third file, I mean, this is not really important. This is a backup file. It keeps a previous copy of my edit. It has nothing to do with compilation. But there is a green file over there, a.out. That's my executable. I can run that program, a.out. I can run that program. So over here you see that it says program already. I mean, this one is text, but this one says it's a program. So if you double click on it, something would happen. I mean, it happens so fast that you can't see. So I'm going to run it over here from the console. / says it's a current directory. Then you type in the executable name. See, it says hello world. And that's all there is to it. I mean, that's the total compilation process and the execution process of a C program. Okay, so let me write this down for you. So let's say we got a C program. We have this hello.c. What are we doing? We are compiling this by typing in what? gcc hello.c. And what do we get as output? We get a.out as the output. How do we run that? We just type this as a.out. So this thing over here, here's my hello.c. That's the source code, right? So I got the source code. That's hello.c. Let me write it down here. That's the source. And then what? Then we compile this. so then we compile this to get what? To get a binary file or an executable file. This is the executable, and once you get the executable, you can execute the program. Then we can execute this. So this is the entire flow of it, really. Like, you have a source code, and from there you compile this to get this a.out. This is the executable, and then you execute this. And this is how a C program works from start to finish. But you type in some code, that's your source code, you compile that to get the executable, and then you can run that. And the way Java works is a little bit different, that's why we're talking about C here. Just so you can relate to this. So to get there, let me type the equivalent program in Java. We're going to type a source code in Java that does the same thing. It prints hello world for you. Okay. So to do that, we write public class. Why we write public class, I will explain later. Then we have to give a name, the name of the class. And this is more like your variable naming. All the rules that you have for variables, they apply here. Excuse me. Like for C variables, you cannot start a variable's name with numbers. Can't do that, right? You can't have a variable name that has multiple words. Can't. It has to be a single word. Okay? So this is how it is. And inside that we write public static void main string args. Okay. And to print something, system.out.printf, like we did before. Hello world. Now I'm trying to save this code, and when we save this, you'd have to remember this also, that if you have a public class, your file's name has to be exactly the same as the class name. So it says hello world with H and W in uppercase. So what we have to write here is hello world just like that. H and W in uppercase, because I have them in uppercase like this. And you have to end this with a .java extension. See, remember, all these C source codes, they end with .c. All these C header files, they end with .h. And in Java, all the source codes that we're going to type, they will end with .java. So I have saved this file, and now I'm going to compile and run this. See, this is pretty much the same code that we have written. Let me go into section 4. We can browse the source code over here. See, again, this is 21 lines, but it has a lot of lines for comments. I have stripped everything, and I have only kept the stuff that I need here. Okay, so that's all. Now if you look into directory listings, I got a new file that's hello world.java, and that's this file. Okay, so we need to know how we can compile this, how we can run this, and that's what I'm going to cover here. The compiler for Java is called javac, JVSC, and then you have to type in the file name, which is hello world for us, right? When you do that, it produces a new file for you. See, we had hello world.java before, and what's new here? Right, hello world.class, this file is new. We didn't have it before. Okay? So just like when we compile this hello.c, what do we get? A.out. When we compile hello world.java, we get hello world.class. But what's the difference? If you look at the color over here, see this one is green, but this one is not. And if you look at the directory from your file browser, you'd also see that. See? This one says this is a program, but when I compile this Java source code, it doesn't say it's a program. It's not. It is a class file, and that's where things are different. Because in Java, you can't just type in hello world.class and expect that it's going to run. No, it's not going to run. You'd have to type in Java space and then the class name. Okay? Why so? I'm going to explain that. I mean, this one runs. That's fine. But this is fundamentally different from how we do it in C. So we're going to talk about the whole compilation process over here again. What we do in Java, this is for C, right? This is for C. But in Java, we're going to do things in a little bit different way. Now, what I'm expecting from you is that you're going to go home and read up these things from our textbook. Head First Java, I downloaded the 36 megabyte version, and this thing loads. I think there's something wrong with the other one. So if you go into chapter 1, let me get there. What chapter is this? Yeah, that's chapter 4. Yeah, this is chapter 1. Alright, so in this chapter, chapter 1, if you look at page number 9, it talks about the compilation process. See, you have a source file, you compile that with Java C, and then you run that with Java followed by the class name. That's how it runs. Right? So your textbook goes through the same process, it talks about it, and also adds a lot more detail than what I'm covering in class. So what I expect from you, when you go back home, read the first chapter. Or the first chapter. So let me get back to this. Let me finish this picture. What we did here in Java is that the source code we wrote is called hello world.java. Then we compile this with what? Java C hello world.java. After that we get what? Hello world.class, but we can't run that. We have to type in Java hello world. Alright? So let me draw the boxes and then I'm going to explain what's happening. So this is our source file. Alright, so we got a source file, and then what we do, we compile this with a compiler. What's the name of the compiler for Java? Java C, right? So for C it's GCC if you're using the GNU compiler. And after that we get a class file. This class file is known as the bytecode. See, over here we're saying that this is executable, but this one is not executable. This is called something called like a bytecode. And then we are running this thing, we're executing this The executing process is something different. We interpret. I mean, this is how this is different. How is Java different? We don't get an executable, we get a class file instead, and then someone else runs that class file for us. And that someone else is a really important concept for us. This is what we call a Java virtual machine. The Java virtual machine takes the class file and it runs on your computer. And that's the beauty of it. See, in C you get an executable, a.out. Say I write a piece of code, that's my source code in C, and I compile this on this PC, I get this a.out. If I email this to you or share this to the group, and if you have a Windows computer at home, if you try to run that a.out, it's not going to run. And the same thing goes, if you have Windows at home, I don't have Windows anywhere, if you give me an executable file, I can't run that. On my Linux PC, it doesn't run. Okay, there are ways to run them, but they're through emulators, but it's not going to run natively. So that's going to be a problem. Like the software that I'm developing, they are limited to a particular platform. If I'm writing for Windows, it only works for Windows. It doesn't work on Macintosh, it doesn't work on Linux. Okay. I mean, we have software that works on different platforms, but they have different versions of the same thing, and you have to get the version for your computer. Like, it also depends on the architecture, whether you have the 32-bit OS or a 64-bit OS. It's not also compatible in that way. But for Java, it works everywhere because what you're going to give is a class file. You're not going to give the source code, you're only going to give the class file, and the person who's responsible for running that, his or her JVM will take care of it. If I'm trying to run this class file on my computer, then my JVM for my Linux is a different JVM than what you have for Windows. It knows how to execute these class files. They will take care of it. And that's why Java has a very unique feature, which is called platform independence. You can compile and produce your bytecode in one place, and you can take it to anywhere else that supports a JVM, and you can run that code. Okay. And that sort of thing, like we see these days as well, when we are writing programs for small devices like mobile apps, Android apps. When you write those things, if you look at the tutorials, or if you will cover that as well, there are a lot of devices that can run Android apps. Can be your phones, that's the most common thing. But Android apps can run on your watch as well, something that you're wearing. It can run apps on your TV. Everything is possible, but they're all different platforms. Okay, one is totally different from the other. So this is what we are looking into, that we have something, it's a really nice thing that you don't have to worry about deployment anymore, where you're going to send your code. You can compile it and get the executable, well, not the executable, the bytecode, and then you just ship it out. Otherwise, what you'd have to do is you have to give your source code to everyone, because they have to compile and build that on their system. For Windows differently, for Linux differently. Either you give out your source code or you build different systems by yourself. It was one of the questions that I asked you for your assignment number 0. What unique feature, or what are the features that sets Java apart from other languages? I wanted you to explore that. So this is the compilation process for Java, compilation and execution process for Java. And if you read your textbook, the chapter that I suggested, it covers all those things, talks about the JVM and what happens underneath. It goes into more details. So really, when you go back home, read this thing. It also explains everything over here. Probably they will not make sense at this point, but read through them. Okay. I love this textbook, not because it has pictures of girls there. That's an added bonus, but it's different from other textbooks. I mean, the way it presents everything with pictures, it has a lot of puzzles, it has a lot of fill in the blanks, right? Try to do those exercises by yourself. I mean, that's a really good way to learn a new language. Okay. So cover at least chapter 1 from your textbook and go through the materials that I have covered today. From next class, we will get into serious stuff. We just looked into the compilation process of a Java program, and I spent a lot of time talking about GitHub and how we are going to share the code, because at this point of the semester it's really important to set it up so that you can get all the codes that we need. And everything that I'm talking about over here, they're also getting recorded, so in case you missed something or didn't understand, you can play it back at home. And feel free to drop by my office when I'm free or when you're free. If you don't understand something, don't just leave it there. Because pretty soon you'll be building large softwares, and you'd be out of clue if you don't follow through. So that's pretty much it for me today. I'm gonna stop it here and give you